Hello everybody, welcome to another screen recording. Today I will be doing a full music theory course, but I'm eventually going to have it, but today I'm doing part 1. Part 1 is going to be all about pitch. So, first things first, what is pitch? Well, let's do a quick Google search. I already know, but you might not, so I can do a quick Google search for you. So Google says that pitch has a few definitions, but we are talking about specifically the quality of a sound generated by the rate of vibrations producing it, the degree of highness or lowness of a tone. That means that basically pitch is like how high or low the note is. So a high pitch will be something like ooh. You probably couldn't even hear that. But a low pitch will be something like ooh. And then there's somewhere in the middle, like ooh. So to demonstrate what pitch actually is, I'm going to show you I'm going to show you guys a graph of an A major chord. You don't have to worry what that even means yet, but in sound waves. So pitch is also known as frequency. And as you can see here, we have this image of that basically is showing a chord here, it looks like. And this is showing you, as you could probably see, it's two different sine waves. It's two different sine waves, you can see that, right? Each sine wave represents pitch. If I go back, we could just look at this, sound waves or sine waves, and then you have the frequency ratio now. So we'll get to that kind of stuff later, but the important thing you need to know is that pitch or frequency is a measure of how high or low the sound is, as in how small the waves are, how quick the period of the wave is. If I tap on the desk, for example, that's a very sharp staccato sound, I know, but that is producing a momentary wave, producing momentary sine wave. If I tap it again, that should give me, I can't really tell the pitch, but that's okay, it gives me a low pitch. But if I sing a note, ooh, this note is giving me, that is a slightly higher pitch than what I got when I was hitting the desk. And that's because if I graphed that note that I was singing as a sine wave, the peaks and troughs will be closer together than, I said, the peaks will be closer together. Same goes for the troughs as with the compared to the desk. So if I pull up Desmos real quick, let me pull up Desmos so I could just show you something. So I pull up Desmos and graph the sine of x. It gives me this. Desmos lets you hear graphs. I know it's really cool, so here goes. So that sine wave is a very it is going very slow. Now if I do sine 2x, you can see it's going quicker, right? The peaks are closer together. Now if I do sine 25x, the peaks are much closer. And now I can hear it's producing a proper pitch now. And now if I go for sine 220x, that gives me, I'd have to zoom in a lot to see the actual peaks and troughs of the wave, but Yeah, that's sine waves. So that's basically pitch. So now let's move on to... So now let's talk a little bit about what specific pitches we use. So we use a system called 12-tone equal temperament. You don't have to worry about what that means just yet. We'll talk a lot more about that later in the course. But we have 12 notes. We have basically 12 notes. And each note has a pitch. And the way we determine our pitches is by what sounds nice to us. Like if I pull up GarageBand and I just start, and I'm going to go to a piano real quick. So if I pull up GarageBand, go to the keyboard, like there are some really nice sounding pairs here. So here are 12 notes. Here's the 3 nicest intervals or pairs of notes. So we picked our system because we picked our frequencies or pitches such that this sounds the nicest. This is called an octave, by the way. This sounds nice too. This also has to sound nice, and this one needs to sound fairly good too. And the reason we need that is so that we could build like that, so we could do something like this, and it'll sound harmonious. That's why we picked our specific frequencies that we took. That's why we have our specific frequencies that we have. And I don't know if you noticed, but all the way down here is a note called C2. This one is C3, this one is C4. The reason for that is that there's 3 C's on here is because this interval, called an octave, is such a nice pitch. Like the frequencies work so well together that they sound like the same notes, just higher or lower. And that's why I say we only have 12 notes, even though there are 88 keys on the piano. So that's pitch for you. So I hope you all enjoyed this a little bit. If anybody has any questions or comments, just post them in the comment section down below. And I'll catch you in the very next video. Mashiach now, Zag Zutton.